Hi, I'm Rob, and I'd like to welcome you to this video, which is a continuation of my final project for CSE IE89 Deep Learning at Harvard Extension School in the fall 2025 semester. My project was a local, multimodal AI RAG agent which ran on a local Ollama server and had a Gradio UI. In this video, I'll demo the enhancements I made, which include deploying the application platform in Docker containers on a Docker bridge network managed by Docker Compose. The containers consist of Postgres and Mongo databases, each in their own container, as well as a container for a ChromaDB VectorStore. The chat UI has been implemented into both an admin application and a client application. The admin app consists of a front end built in Next.js with an Express backend, and the client app has a Flask front end with a Fast API backend. These are all deployed in separate containers. There's a new Fast API AI agent app that receives chat query requests from the admin and client apps and uses intelligent routing to determine if it needs to query the Postgres or Mongo databases or the Chroma VectorStore. The models for the agent run on Ollama in a container and use Nomic embed text for creating the vector embeddings and Phi3 Mini for inference. Additionally, there's a systems dashboard built in Streamlit that displays the status of the services. And to launch the app, I've provided a deploy shell script that you can execute after ensuring Docker is up and running. Note that deployment took about 5 minutes on my M1 Mac, so I'm going to trim and fast forward the process in this video. Okay, now that the app is deployed, let's take a look around, starting with the systems dashboard. Here, we can see that all systems are operational, with a list of each service and its current status. Quick Statistics tells us we have 9 total services, all of which are healthy, and in our database, we have 354 total records. Now, these are the records that were inserted into the Postgres database from CSV files. And looking at the data summary, we see a breakdown of the 354 records. We see that there are currently no registered users in the Mongo database, and that the ChromaDB VectorStore has 1 collection with 76 documents. Scrolling back to the top and clicking into Postgres, again we see a breakdown of the data stats. And in Mongo, again we see we don't currently have any user profiles. In Chroma, we see our 1 collection and 76 documents that are in the knowledge base, and we can test a ChromaDB connection, which we see is healthy. The admin backend has a health check and Swagger docs. The admin front end has a link to launch the front end, which brings us to the agent support dashboard. We can view our policies, customers, claims. There's an AI chat and a document management page, which will allow us to upload additional PDFs and store them in the Chroma Vector database. The client backend also has a health check and Swagger docs. The client front end has a link to the front end, which allows users to register, log in, and chat. Next, there's a tab for Ollama, where we have two models. The first is the Nomic Embed text model and Phi3 Mini. And if we scroll down, there's links to the Ollama API and the models, and we can test the Ollama connection, which we see is healthy. Then in the AI agent, we see the status of the ChromaDB VectorStore, the Postgres database, and the MongoDB are all connected, that Ollama is connected, and the overall status is healthy. Again, there's quick links to the health check and the Swagger docs, and we can test the connection to the AI agent, which we see is healthy. Then finally, there's a tab for the deployment logs, which we can search. Now, I'm going to resize the browser, jump into the admin front end, and open the chat UI. I'll also open the JavaScript console, then tail the AI agent logs in the container. Now, I'll submit a query from the admin front end to the AI agent asking, what is Agentic AI liability insurance? Here in the logs, we see that the query was submitted and it's using RAG, that it retrieved 3 documents, and it's sending them with the query to the LLM. If I expand the request in the JavaScript console, we see the content of the query and the role, as well as the user ID of admin and temperature and top case settings. The user ID of admin allows the agent to search the Postgres database, Mongo, and the VectorStore. And when the response is returned, we see the agent used RAG. Now, let's send a query asking how many policies are in the database. And we see the agent queried the Postgres database using SQL to find there are 208 policies. And now, let's ask how many registered user profiles there are. And we see the agent went to the MongoDB and didn't find any registered users. Now, let's jump into the client app front end and open the chat UI. Now, we'll send a query asking, what is AI Agent Insure? In the JavaScript console, we see the request message, which has the content query and the role, and a user ID of guest. When the user isn't authenticated, sending the ID of guest allows the AI agent to only query the VectorStore. And we see the response. Now, on the client app chat UI, in addition to submitting text queries, speech is also supported. Who is the CEO? As is audio playback.
The CEO of AI Agent Insure is Dr. Amina Rahman.
Now, let's submit a query asking how many claims there are. And we see the agent replies indicating that it can only provide information from the company documentation and knowledge base. But if you log in, the agent can query the Postgres database for policies, claims, and customer data for the specific authenticated account. So let's register a new user, providing an email address and policy number currently in the Postgres database. then log in. And here we see some information specific to the authenticated user. And now let's ask how many claims there are. And we see the response indicates there are no claims for this current policy. So the agent was able to query the database, but only for information related to the authenticated user's policy. And that information is sent to the agent as part of the request, which we see here in the JavaScript console. And now that we have a registered user, let's jump back into the admin front end and resubmit the query, and we see the updated result. Now, in order to demonstrate updating the VectorStore with new data, I'm going to submit a query which the agent has no idea how to answer, because it's a question about Formula One racing. I know this is a contrived example, but it clearly gets this point across, so bear with me. I'll ask, who won the 2025 Australia Grand Prix? And as expected, this event is outside the agent's documentation scope. Now, I'll click on the document link on the admin front end and upload a PDF document which has race results from the 2025 F1 season. And back in the chat UI, I'll ask again. And we can see Lando Norris won that race, which we can verify in the PDF file that I uploaded. Finally, I've provided a destroy shell script to tear down the deployment. So that concludes this demo of my enhanced project. If you're interested in taking a deeper dive into the actual building of AI systems, keep an eye out for upcoming videos in my AI engineering hands-on playlist. Thanks for watching.